For the area of a circle, every circle must have a center. So this is our center here. So we're just going to try to divide this circle into 8 equal parts. Now it's not compulsory. You can divide it even up to 16 equal parts as the case may be. So for simplicity, let's divide into 8. So you see that now if I bring out a portion of these our divisions, let's say if the first portion, you see we have something here, right? So what do you notice? You know from the center to the point on the circumference is the radius, right? So that means these two lines here must be what? The radius. And then this curve here is called an arc. As you can see, is a part of the circumference, right? This curve here is an arc. It's just a part of the circumference. So what is this area inside here called? It's called a sector. So this is called a sector. Alright, so what is the sector of a circle? A sector of a circle is a portion of the circle that is bounded by two radii. So we have two radius and then an arc. And an arc, remember I said this is called an arc. An arc is just a portion of the circumference. So to derive the area of this circle, we are going to arrange these sectors like this. Alright, we're going to arrange these sectors in this way. Right, so we can easily derive the formula. Now when we have arranged these sectors in this way, you see that it forms somewhat like a parallelogram, right? So you can use the basic knowledge you have from parallelogram to derive. So first of all, let's consider some things. Of course, the first thing you should know is that this distance here is what? Radius. So this will be what? Radius. Now, let's look at the first half of this circle, this point. When we look at the first half of this circle, you see that it's a semicircle, right? That means from the first sector to the fourth sector, it's going to form a semicircle. And if it's a semicircle, the circumference, of course, remember that circumference of a semicircle is we have is half the circumference of the circle. So half times 2 pi r, right? So 2 can cancel 2. So we have our formula as pi r. So that means that this the circumference of this semicircle is going to be pi r. And see the way I've arranged this my sector, we also have the first one, second one, third one, and fourth one. Then the arcs, the sum total of the arcs is going to be the circumference of the semicircle. So that's what we have here as what? Pi r. So take note of that. Also, if that place is pi r, this place will also be what? Pi r, because from 5 to 8, from the fifth sector to the 8th sector is also a semicircle, and the circumference will be pi r. So finally, how can we derive the formula? So since this is a parallelogram, our area, so area of circle will be what? Length times breadth, right? So the length is pi r, the breadth is r. So finally, our formula will be what? Pi r squared. So this is how to derive the area of a circle. There's another way to derive it, but I think this one we are good to go. So that's the area of a circle. Don't forget pi r squared. So let's go further. Now, this shape here is called what? A trapezium. So this is a trapezium. So we're going to derive the area for a trapezium. Now to derive the area of a trapezium, let's try to divide this trapezium into two shapes and then we get the area. Let's divide the trapezium into shapes that we already know the area because we've already derived some formulas. So I'll just draw a line from this point. Alright. Now when I've done this, see that I've divided the shape into two parts, the first part and the second part. Now you see that this part is a rectangle while this is a triangle. So let's call this part A, let's call this part what? B, and let's call the height H. So if here is H, here will also be H, of course, yes. And then let's call here A and B. Why I'm calling here B is because this is the distance from this part, alright, to this part. So I can't call it A, seeing that A and B are not of the same length. Alright, so that's why I'm calling B. Okay, let me just make a space. I want to prove a point there. So I'll get rid of all this. Okay, so I'm going to put the B somewhere here so that the whole of this is what? B. Alright, but from here to here will also be A, right? Since this is uh, a rectangle. And then from this point to this point, what is it going to be? You see that this point to this point is going to be B minus A, right? So that makes sense. So this is what we have. So we're going to have that the area of a trapezium is equal to the area of the rectangle plus the area of the what? Of the triangle. So this will give us the sum area of the trapezium. So let's derive the formula. Area of rectangle is what? Length times breadth. So our length now is A. So I have A times our breadth is the h, which is the height, right? A times height. Then we add it to area of triangle is what? Half base. What's the base of this triangle? Remember B minus A, right? That's the base. So half B minus A. Let's put that in the bracket times what? The height, which is also what? H. So A times H is simply AH plus half B minus AH. So we are going to factorize to get our final formula. So what is common? You see that H is common, right? So since H is common, we're going to factorize. Or rather, let's just expand this. We have AH plus B minus A all over 2, times H. So again, H is common. So I'm going to factorize. So finally, our area A is equal to, since H is common, I'm going to put it out. And then we have A there because H is going to cancel H. You have A plus B minus A all over 2. Alright, so I've already made a video on factorization. So just in case you don't understand how I'm factorizing, you just search go to the channel, you're going to see the video on factorization. Or I'll also drop the link in the description below. So let's simplify the brackets. We have our area as H into, so we have a common denominator of 2. So this over 1, right? This A is over 1. So 2 into 1 is 2. 2 times A is 2A plus B minus A. So this is what we have. So finally, we have H equal to, let's collect like terms there, 2A minus A plus B all over 2. So our area A is equal to H bracket 2A minus A is what? A plus B all over 2. So this is the area of a trapezium. This is the formula. In some textbooks, you're going to see it like this. The area of a trapezium is equal to half bracket A plus B times height. Now this is the same thing because if I put this edge the other side, remember 3 times 5 and 5 times 3 are the same thing. So I can just move my edge to the other side. So sorry. So I have A equal to A plus B all over 2 times H, right? Then for the A plus B, recall that A plus B is the same thing as A plus B over 2 is the same thing as half times A plus B, right? Since 1 times A plus B is still A plus B, 10 times the height. So that's how they got this formula. So please take notes. So our area of trapezium is half A plus B times the height. So that's how to derive the formula for the area of what? A trapezium. So what about the area of a parallelogram and a rhombus here? So just like perimeter, the area of a parallelogram is the same with area of what? A rectangle. While that of a rhombus, so I'm just going to represent the shapes. So let's say these are parallelogram. Here will be the length, here will be the breadth. These are rhombus, all sides are equal, right? So the area here for parallelogram is going to be length times breadth, while the area here is going to be L times L, which is L squared. So that's it for a parallelogram and a rhombus. It's always the same with a rectangle and a square. So we've successfully derived most of the formulas for calculating the area of plane shapes, regular plane shapes. So I hope you found the video interesting. If you did, please share with your friends so they can learn too.